Hi everybody, welcome to another video in statistics, section 10.2, hypothesis test for population proportion. So this case we actually have some problem that with some numbers that we can work with to see the logic and the language of hypothesis testing. So the logic here, we observe the results are unlikely under assumption that the null hypothesis is true. And instead that we say it is statistically significant, and when results are found to be statistically significant, we reject the null hypothesis. For hypothesis, the level significant alpha is given. Right. So there will be two approaches. One is the classical approach, and the other one is p-values approach. In this class, we have a calculator, so it is easy to use the p-values approach. So we stick with the p-values approach, but I will explain both. Alright, so first we know the alpha. We can separate the region corresponding to the null and the alternate hypothesis. For example, let's just say alpha is that much. And with that, we separate the bell curve into two regions, one on the right and one on the left, right? And the statistical, of course, the mean is right in the middle, right? The mean is in the middle. So the statistical is no difference, no change. So the statistical will be wherever it is at the middle. So this is where we say this is the H0, and the other one will be H1. So the alpha is given, so we can establish whatever it is, the H0, whatever is H1. Right. Next, we compute the test statistic from the sample. In that case, we gather the evidence, we gather the sample information, and we compute the test statistic. And with that test statistic, we will have the z, what we call the z0. So if the z0 stand in this region, that will be reject the null hypothesis. If the z not stand in here, that will be do not reject. So this is will be reject the null hypothesis and do not reject. So it's like before, and then we establish that boundary is this much, or we said the reasonable doubt that is in the core system, that is called the reasonable doubt. If it is way more than the probability of the person did that is a lot higher than that, then it's guilty, or that, right? But that's actually more easier to explain in the p-values setting. But so that's what we have. So the alpha is given, we compute that. So next, that is the classical approach. From the alpha given, we establish the boundary, and then we gather the information for the sample, or we say the evidence, and we find another values. Will that value stand on H1 or stand on the H0 region? If we stand on the H0, we do not reject. If we stand on H1, we reject the null hypothesis. Right, next, the p-values. The p-values is the probability of observing a sample statistic as extreme or more extreme than observed under assumption that the statement of the null hypothesis is true. So with this, like I said, alpha is given, and from that we arrive the p-values. I'm sorry. So again, this is alpha, and then we said if the p-values is more than that, if the p-values is more, so the bigger tail have to be like this, right? So if the p-values is like that, so this is equivalent as it stand in the H0, right? So if the p-value is bigger than that, then we do not reject. If the p-value is smaller, than that, then we reject. So if it is too small, reject. So the p-values approach, if the probability of getting a sample statistic as extreme or more extreme than 1 of 10 is small, under assumption of the statement of null hypothesis true, we reject the null hypothesis. So I just simply say this: if p is less than alpha, we reject it. Right. So, and there's three different: the left tail, right tail, right tail, and two tails. Right. So let's just say it in the chord system. I'm trying to draw a conclusion to the chord system. It's easy to understand. Right. Let's say it. I try to put some numbers here. I say before we go to the court, say you are a jury, to say it. If, by the way, the status quo is always innocent. On this side is innocent. On this side is H1, so innocent. And this is guilty. Right. Let's say before you go to court, you say, unless you sure that is 5%, and there's only 5% that you are wrong, then you say the person is guilty. If you believe the person is guilty with no more than 5%, let's say you establish that 5% is your reasonable doubt. And then after you hear the evidence and you said there is only 1% that if it's less than 1% that person is guilty, then or we say it is beyond the reasonable doubt. In that case, we have to reject the null hypothesis, so that person is guilty. So I should say this: if you say that 5% is the boundary, or that means 95% the person is innocent. If it is more than that, then of course you let that person go free. But again, if it is less than p is less than alpha, we reject the null hypothesis. So if it stands on this side, the tail is smaller, then we reject the null hypothesis. And in that case, the person is guilty. Right. Now we get to some technical calculation. The samples is the simple random sample, or we need this, or so that actually like in chapter 9 we have this criteria. The sample values are independent of each other, right? The computation. Review. The best estimate for the population is this. So this comes from the sample X, and N comes from the sample. And in this case we say that is the evidence. And so we can calculate the standard deviation of that. And the test statistic is going to be this. Again, this is the evidence. Or from sample. And the P naught is assume that it is true. Yeah, that's what we have here. Right, so that is we calculate this, and we use this for the classical approach, and the p-values we do not use that. We use different way. Right. So the steps, of course, we have to determine the null hypothesis and alternating hypothesis. That's the first step. Always do that. Next, select the level of significance. Usually that will be given, and then we compute the test statistic, or equivalently we'll calculate the p-values. And then the classical approach, based on alpha, we define the region, and then with that we know when it stands on, and we make the conclusion after that. Right. So I'm going to summarize everything here in this few sentences. Right. HO, the null hypothesis, is for the status quo when P is low, then it must go, meaning we reject the null hypothesis, reject the H0. So HO is for the status quo when P is low, then it must go. Keep that in mind, we'll see that in a moment. Right, an airplane claims that the no-show rate for passenger is less than 5% in a sample of 420 randomly selected reservation. 19 were no-show. At alpha 0.01, test the airline claims. Right, like I said, later on we will use only the p-values approach, but on this first example I'm going to do both. But first, let's check the steps. The first step is determine the H0 and H1. So the step number 1, the hypothesis. This will be the same for both approach. Determine the hypothesis. So it's not H1. Right. The airline claim that is less than 5.2%, and that is the proportion. It's less than 5%. Right? It doesn't have the equal sign, so it has to be H1. 5%. And the null hypothesis is always equal to. This one is less than, so this is a left tail problem. So that's what we have first. And then next, we have alpha is given. So the next step is select alpha, or in this case alpha is given. Right. And now we test the hypothesis. So the step is the computation after this. So the computation and like we said, we use two different approaches here, the p-values approach and the classical approach. Later on we only use the p-values approach. Needs the p-values. Right. Now, for the p-values approach, let's see the set. The test statistic is this. Okay, keep that in mind. But first, classical approach, we have alpha 0.01. From there, we can determine the z alpha over 2, or the critical values. Right, alpha 0.01, this is on the left tail. What does that mean? That means the alpha will be on the left of 0.2. So I will find the threshold here, the values corresponding to this, which is inverse normal. Of 0.01, and that gives us negative 2.33. Right, from alpha 0.01, that's what we get. So that is the threshold. The status quo on this side in the middle, and the tail end is alternate hypothesis. Right. So after that, we will calculate the test statistic to see where it lies. Right. We know in the problem the p hat. This is the p naught. So we calculate this, but first the p hat. The p hat is come from the sample or come from the evidence for the sample. The p hat is equal to x over n. In this case, x is 19 over 420. It is 0.45238. So that is p hat. Now the test statistic in the classical approach, test statistic z naught equal to p hat minus p naught over square root of p naught 1 minus p naught divided by n. Right. So, by the way, we just did that, right? Right. Next, we compute this alpha y equal to, and that gives us a fraction. Right, p hat, whatever that number is, subtract the p0, 0.05 over square root another fraction, p naught 1 minus p naught, p naught meaning p sub 0, divided by the n, 420. Right, do that, we have negative now, and then the next, this number is on the right side here, right? We get the test statistic then in here, which is in the H naught. So that means it is on this region, so we do not reject. So do not reject H naught. Right. So that is the classical approach. Of course, later on we'll write the conclusion in a bit, but that is the calculation for the classical approach. Right, in the p-values approach, we use the fact that the p hat, we're going to keep the alpha, we just use the p is 0.05. I mean, we're based on the sample, and from there we do the math. So for the sample, x equal to 19, n is 420, From this we have the p hat. So exactly like what we did earlier for the classical approach, but here different. What we calculate is what will be the percentage corresponding to this much. Right? So what we actually do is pretty much the calculation is the same. We're not based on this. Let's say we have the z naught is we do the same calculation and we get z naught is negative 0.447. However, we did not do this. Right. So whatever here come from the sample independent of what the alpha given. So we do not have the graph. We do know the z here though. And what we do after this is we calculate. Right, so we always calculate the z naught. But for classical approach, we take the z naught, we compare to whatever the inverse norm we get from alpha. For the p-values approach, we do not have that. We just have the z, still the same calculation. But now, if the z is negative 0.447, and we know this is the left tail, we will calculate the corresponding p-values. So now that p-values will be equal to whatever the area is. So that will be just normal CDF. From the far left, where that number is good, up to the upper values, negative 0.447. And we compute the p-values will be 0.327. And here we have the p-values is greater than alpha, so that do not reject. Right. So difference between the z-values approach, the p-values approach and the classical approach is that in the classical approach we use alpha to calculate the criteria, the critical values, and then the test statistic we can compare it with the test statistic. In the p-values approach, we do not, based on the alpha, we do not find the critical values for alpha, just keep the alpha. We still calculate the test statistic, but then we calculate the p-values corresponding to the test statistic, and if it's greater than alpha, p greater than alpha, do not reject. And we reject it when it is less, or when p-values is low, meaning that is small values, then we reject it. So p less than alpha, we reject it. The good thing is we don't have to go through all of this problem. The calculator will calculate the p-value for us. Right, so this is how it goes, just like this. His stat, go to test and go down to 1 proportion z-test, right? And the p-naught, that is where the numbers in the problem say that less than 5% is no-show, and x we have 19 out of 420, and this problem is less than, so we choose that, and then we calculate. The p-values is 0.327, bigger than alpha, do not reject. And finally is the conclusion. We do not reject it, so it is, there is not enough evidence to support the claim that is less than 5%. So there is not evidence to say that it is less than 5%. No show raise. is less than 5%. Right. So, like I said, we just use the p-values here, and we just use the calculator. And if p is greater than alpha, do not reject. If it's less than alpha, we reject. So it's as simple as that. Oh, by the way, how do we use the StatCrunch? StatCrunch. So we go to stat, proportion, one sample, and summary. 19 and 420 here. Alpha 0.0, p naught 0.05, and this is left tail. Right. So this is exactly like what we write for the null hypothesis and alternative hypothesis, and with the evidence from the sample. And that enough, just hit compute, and that gives us the p-values here. Right. Right. And when we have the p-values, we can determine reject or not. Right. Here's a couple of more samples here. A coin is tossed 1,000 times. 520 heads appear. At 0.05, test the claim that it is not a biased coin. Alright, so first is the hypothesis. H0 and H1, the null hypothesis. So whether it's the biased coin or not, the status quo is the coin is not biased, meaning that the probability of getting head is exactly 50%. And the alternative hypothesis, this is not a biased coin. So that is the H0. The biased coin, we mean that it is not different than 0.5. And it's not equal to, so that will be two-tailed. That's very important. We have to determine that before we do anything. So that's the first step. And then the second is establish alpha, alright, 0.05. We don't need this if we use the p-value approach. We only compare this at the end. Right, next step is the computation. Right, and we use calculator. So in this particular sample of 1,000 times, x is equal to 520. And at that much, test the claim that is not a biased one. Right, so computation. Second variable, stat, go to test, one proportion z test, and p naught, that's 0.5. So when we replace here, we have p is not equal to, so we will highlight that. So p is not equal to 0.5. That's what we have, right? P not equal to 0.5. So p naught is 0.5. X 520 out of 1,000. That's 10,000, right? 1,000. And now we calculate. The p-value is 0.2. And alpha is that. So the p is bigger than alpha. So do not reject. And then we have the conclusion. There is not enough evidence. Yeah, so if we have a calculator, that's all we write. So there is not enough evidence. To support H1, to support that the fact or just to say that the corn is biased. Right, so if it is do not reject, there is not enough evidence to support H1. Right, so not equal to 0.5 meaning bias. Here's another example. A recent study claimed that at least 15% of junior high students are overweight. Example 160 students, 18 were found to be overweight at 0.05. Test the claim. Right. Now first, this is at least 15%. So P at least meaning greater than or equal to 15%. Right? At least meaning that or more. At least 15% or 15% or more. So first, the hypothesis. H naught this one has the equal sign, so we have to write the complement, which is less than, and we have to choose whatever doesn't have the equal sign. That will be H1. And whatever the null hypothesis has to be equal to. And this is less than, so it will be the left tail. Right. Next, alpha 0.05. Keep that in the back pocket. Now the computation. What we have from the sample, n is equal to 160 and x is equal to 18, and with that we compute the p-values using the calculator. Right, stat go to test 1 proportion z test, and we have to write this statement. So we say p is less than p naught, where p naught is 0.15, x is 18, n is 160. Right, so 0.15, 18, 160 less than p naught, and then calculate. We have the p-values is 0.09. Right, actually, let's change the prompt to 0.1. So in that case, we actually have something that we reject. So this, right, let's change the prompt to 0.1 alpha. Now, the p-values is less than alpha, so we reject. I just have one prompt, so we reject the null hypothesis, so we will write, just want to write the conclusion based on when we reject it. Right, remember, change that, so we have the reject here. Right, reject, so there is enough evidence to support that, to say the proportion is less than 0.15, so meaning that the rate of overweight is less than 15%. Right, so we support the H1. Right. Oh, just make sure we have to use the StatCrunch. So StatCrunch, we go to stat and proportion stat one sample with summary. Have to be careful here. We have X is 18, number of observation 160, and we write exactly as the statement. Null hypothesis is p equal to 0.15, and it is less than. Alright, and now that we hit compute. Right, we have 0.092. That's exactly like we have for the p-values, and the p-values less than alpha, so we reject the null hypothesis. So in this section we do the hypothesis testing on the population proportion, and we use the p-values approach. But that's all we cover in this section. Like I said, I prefer to use the p-values approach, and we use the calculator to go with that. I'll stop the video here. As always, thank you for watching, and see you in another video in statistics.